Good morning, everybody. Welcome to our second session. Mike Gretzinger is going to walk us through some hemp agronomy plots and talk to us about some of the research that's been taking place over the last few years here. Apologize if the video streaming is glitching. We are continuously working at trying to improve. By all means, let us know. There's a survey link that was sent out in the email. Please consider sending us some feedback. And if you're looking for CTA credits, we have them coming. They just didn't send us the QR codes, but I've talked to them and we're just going to submit the registration sheet. So everybody that signs in will have their credits added for the sessions that they join. And don't forget to join us again on July 9th. We've got our Farming Smarter Field School, and we'll pass it over to Mike.
Yes, sir. We're live? All right. Welcome to Hemp Agronomy. I'm Mike Gretzinger, and I'm going to give you a little bit of past, present, and future hemp research that we're doing here in Farming Smarter. So I'm going to start with a little bit of background. We've been growing hemp for 5 or 6 years now here, and it all started with a little bit of conversation with Dr. Jan Slasky out of Initech, Alberta, formerly Alberta Innovates Technology Futures. And we might have done some work on a presentation or something like that, but he asked us to do a variety trial in southern Alberta, and he was looking for some data between southern, central, and northern Alberta on hemp production. And so, you know, like any agronomist or thing like that, we get really excited about growing novel crops here. So we really didn't know what we were doing 5 or 6 years ago. And he explained that shallow seeding, treating it really like a small oil seed, we're going to need maybe a moderate amount of nitrogen. And, you know, don't worry about pests. Hemp's been grown for a long time. It grows organically. You know, people have no trouble growing it in their basements or gardens. It's been around for a long time. So we should have fairly good success as long as we do a few key things right. And those being kind of getting our seeding rate and our seeding depth right. So we grew hemp in year 1. We did a variety trial. Everything made it to yield, and it went from there. So what we did after that was we put a program together, and we did a 3-year agronomy study, and that was a much more robust study. So we kept the variety trial. So there was only, I think, 20 or 30 commercially available varieties at that time. So we took a select number of those and we put them in the trial. And then we looked at a fertility. So we made a nitrogen fertility response curve. And then we looked at seeding dates, and we figured the differences between southern and northern Alberta are pretty drastic. So we expected to see some pretty big differences between some of the different things that happen with hemp. So if we're to look at the seeding dates, for instance, right here in Lethbridge, we just passed the solstice, June 21st. We're still, though, about an hour and a half shy of the daylight hours that they're getting up in northern Alberta, up in the Peace region. So there's a really big advantage that they have up north called the Northern Advantage, and that's where they're, you know, getting a lot more robust biomass fiber production potential compared to what we have down south here. However, that said, seeding dates were a lot earlier here. Oftentimes, May long weekend, we're trying to wrap up seeding so we can all go camping, whereas up north, they're hoping for the snow to melt off and start planting. So very big regional differences in this program, and that's really exciting. Then we did a fertility trial. So our fertility trial, we made a nitrogen response curve, and what that means is we picked a select number of rates. We picked 30, 60, 90, 120, 150, and 180 kgs per hectare of nitrogen. And we literally got a bar chart in the field. So you could start down where we had no nitrogen added, 30, 60, 90, and you could see how much more robust and vigorous the plants were as you continue to add more and more nitrogen. Now, hemp's a pretty unique crop. It'll take about 70% of that nitrogen and it'll pack that into the biomass. So you really see a visual response. But when it comes to yield, it's not as cut and dry. Only 20 to 30% of that nitrogen is actually making it up into the grain. And so that's where we get a little bit more nuance moving into our current research. So really, to summarize our first 3 years of research, the varieties we found were all pretty well suited for southern Alberta. The biggest key was for new growers, just picking a variety that was going to suit their logistics of their operation and what they were going to do. And what that means is hemp, we used to call it a triple threat crop, and now it's a quadruple threat crop pretty quickly here. And that means it's used for feed, fiber, food, and fractions. So feed is that robust biomass, the 10, 14 foot tall hemp plants that'll be towering over us like some of these will in just a month or two. Food is generally where we've focused. Food is the grain. Food is what comes out of the seeds on the female plant. And that's the stuff you're going to see in your granola bars and on the shelves at a Costco. I might have said that wrong. Fiber is the biomass. Feed refers to something the Canadian Hemp Trade Alliance, which is a group that is focused on promoting hemp in Canada. It's something that they've been working on a lot in the last couple of years. And feed means, what are you going to do with all that extra biomass? Sometimes you might not have an end use. It might not be good for clothing, or the economics may not be there to use it for something else. So you may just want to use it for bedding. You may just want to bale it all up and feed it to animals. So they have to make sure that, because there is some relation to recreational marijuana, they have to make sure that all that's going to be safe down the food chain. And then fractionation, that refers to obviously the CBD. So that's looking at taking samples from the plants, looking at CBD, looking at THC concentration. There's hundreds of different phenols and cannabinoids that are in the leaf and can be used for various purposes. And we're really just at the tip of the iceberg as to what those can be used for specifically and concentrated for. So variety, getting back to the story, variety, it really depends on your end use. That's the most important thing that we found. For fertility, it really came down to, again, kind of end use, but what your background looks like, and we know the response is there, but what are you going to do as a producer? So we found that about 200 kgs per hectare was the optimum amount for, say, an irrigated field in southern Alberta. That may range a little bit throughout the province. So we tend to take that approach. We're going to sample our fertility in the spring. We're going to get a background and then take 200 and subtract. And from there, we're going to figure out about how much fertility we want to put on to get an optimum amount. Depending on the economics of fertilizer prices and your seeding costs and things, you may need to bump that up or drop that down a little bit. And then finally, seeding date. And now seeding date, it was a really big surprise. We'll get to seeing the plots over there in a little bit. We were told, don't worry about it. Hemp, you want to seed later. That was kind of the first message that we got when we started growing hemp. You want to seed later. Wait until after May long, go on your camping trip, do whatever you're going to do, and then come back into the field, seed your hemp. And now, there's a lot of reasons for that, and I think a lot of them are really good. So for example, when it comes to novel crops, we're growing quinoa, and that's one of the strategies that we're using. And that's because we have limited broadleaf control in this crop. And so to wait for later in the spring, you're going to get warmer soil temperatures. The seed's going to germinate in like 2 or 3 days as opposed to sitting in cool soils for 10 or 15. And you're going to get a nice nice rainfall, and you're going to have a flush of weeds come up that you can then burn off before you go in and plant, as opposed to having them between the rows competing with your hemp. So there are a lot of benefits to delayed seeding, especially in a crop like this. But what we found was in our southern region, we could definitely get earlier. And you know, some guys were delaying as far as like June 5th, 6th, being like, yeah, okay, it's June, I guess I'll go in and seed my hemp. And as great as that is, we found that our grain yields could really be improved by seeding earlier. So our optimum rate here is about middle of May, but we've seen even going in early May, we've got some pretty significant yield bumps depending on the year. So one of the things we found was, you know, we never had our best yield seeding in June. It just didn't happen. The earlier the better. So 3 of 9 years, the 3rd week of May that we seeded here, we had our best yield, but actually 6 of the 9 years here that we seeded early May, that was our best yield. So we have seen guys go kind of earlier and earlier, and that's what some of the producers in the area have been telling us, that yeah, okay, I'm definitely not doing June anymore, maybe last week of May, maybe second last week of May now. But obviously there are some logistical challenges when that happens, and we'll get to that over there. So I think I'm going to get into what we're doing now, because that's kind of a good background of what we've done before. And I get to get in and show you some of these plots. This is the 2nd year that we're doing this. So we're again going with 3 locations. We have a location here in Lethbridge in southern Alberta, one in Vegreville, which is central Alberta, and one up in the Peace region. And so we're going to replicate this fertility and the seeding rate and date trial there for over 3 years. So this is our 2nd year on that. And what we're looking at is we're looking at that agronomist approach. So we've taken our background soil tests. We know we need about 200 kgs, and like we mentioned before, we had about 40 pounds per acre in our background tests here of N, and we had about 20 pounds an acre of P2O5. So when we do our math, we're targeting about 160 kgs a hectare of N and about 40 kgs a hectare of P2O5. So I've got a couple plots here, and maybe I'll just walk you through them here right away and show you what some of the treatments are and what we're seeing. The plot to my right here, we can maybe play a little game. I guess you guys have the signs, but this plot to my right here, this is our check. This had 0 N. It only had 40 pounds an acre background N, nothing else added to it. So, you know, when you hear the myth that you don't need to put any fertilizer on hemp, I mean, yeah, it'll definitely grow without fertilizer, but the plot beside me is 100% of that nitrogen rate, and you can see how robust and you know, height-wise, you can see how much taller it is. You can see how much darker green. It's such a rich dark green. And interestingly enough, I noticed earlier just waiting around that there were a lot more bees flying around here, probably because it looks like it's almost starting to mature a little bit quicker. There's a lot more kind of purpley heads on some of these male plants that are starting to produce pollen already. So maybe some consequences that way too. So what we're getting at, I think, with this fertility trial is we're trying to dig into some of the nuance and some of the higher end agronomy. One of the questions we get is like, what about fertigation? Well, we can't study fertigation on this site here, but we can do some dribble banding. So with this treatment here, we would have dribble banded 25% of that UAN 4 weeks after seeding. So we would have taken another 40 kgs a hectare and then gone in with our lines and fertilized it that way. So maybe just come on a quick little tour and we can show you some of these plots. So our untreated check, it's very light colored. It's maturing a little bit earlier. I think the yield is definitely going to be down there. We've got 100% N plus the UAN. So this one's actually going to get a split application of UAN. We did 4 weeks already. We're going to put a little more UAN again 8 weeks after seeding. So we're hoping this is going to be like our kind of our premier plot. But it may be that we're over applying nitrogen. And so we've got a couple treatments to kind of show the difference there. So for example, we also decided to do one with ESN, and that kind of simulates that slow release nutrient uptake later on in the season, so we're not putting it all down right at seeding. So we've got 75% upfront at seeding and 75% N upfront at seeding and 75% ESN upfront at seeding. And then we also decided, well, if we can go above and beyond just nitrogen for this study, we're gonna match all of our rates. We're gonna match the phosphorus rate. So if we're doing 100% nitrogen, we're gonna put down 100% of that phosphate, which is another 40 kgs per hectare, like I said. And then some of these we're actually putting a foliar boron, like a foliar application, and that's just because we're not sure what kind of micronutrient requirements that there are out in the field here. So I think if I show you, say, this plot here, this is our 50% N, 50% ESN, and we did a micro application on it. It looks pretty comparable to our 100% N. I actually feel like it looks a little bit better, and that could be because of that slow release ESN as well as the micronutrient that it would have got last week. I think our 100% or 150%, which is a 75-75 ESN split, I think that's looking really good. And then funny enough, kind of touring around even without looking at the signs, it's really easy, maybe harder on camera, but I think we can even pick out some of the 50% N plots. So go back here. Might be tougher from the back. I'll wager a guess that this one is a 50%. Yeah, so this is our 50% nitrogen, 50% phosphorus plot. And you can just see it's a little bit shorter, it's not quite as dark and robust, and you almost see a little more purple in all the heads, and I think it's maybe a day or two earlier here. So we're really hoping that we can see something useful for producers. One of the challenges of this is that, you know, because we've had some pretty good growing conditions under irrigation the last few years. I'm trying to find my chart. I don't recall last year, we have one site year here, but I don't recall us seeing a yield difference. The only thing that I think is going to show obviously is this check here, but you know, the important part is I think if we're hitting that 100%, the method may not matter as much. That's probably one of the 4 R's that matters the least in this case of hemp. If it's getting the required nutrients, it could be dribble banded on, it could be fertigated on, it could go all at seeding. It's probably, as long as it's getting it, the plant's going to be happy. So it's kind of the take home for there. We're going to jump over to the rate and date now. So we're just going to go for a little walk. All right, hemp 1.0, I said we did seeding date trial. We did a couple of different dates, and we found that the earlier the timing, the better we did. But one layer that we didn't add in there was a seeding rate. And so when we're doing seeding rates for hemp, it can vary a little bit depending on whether you're trying to grow for grain or grow for fiber. The guys who are growing for fiber tend to bump their seeding rates up a bit, and that's because they get a lot thinner, easier to manage hemp plot, and the fiber balance between the herd, the inner and outer fibers is better for production, and it's a lot more uniform within the plot. Now, if you're growing for grain, as we've seen with some of our other planter studies and things like that, it's pretty tempting to cut rates, and especially when hemp seed's pretty expensive, guys want to cut usually as low as they can within reason. So what we're looking at with this seeding rate and seeding date study is, what is the effect between the two going to be? Like, what is the interplay? So if we have, you know, really good optimum seeding time, and we've got really good agronomy, our drill's calibrated well, we've got good soil conditions, we've got good environmental conditions, you know, are we going to be able to cut our hemp rates and get away with it? Likewise, if things are unoptimal, if we lost a field of canola to wind shear and we decided to reseed it, and we happen to decide to reseed the hemp, you know, should we be bumping our rate up, or should we just put what we can down and hope to get something out of it? So, you know, kind of the practical side is what we're asking with this study. And you know, you can see by looking at the variability of the plots behind me just how drastic it is. The difference between our seeding rates was only 2 weeks. Our first seeding rate, oh, I lost my page. Our first seeding rate was May 7th, and that's actually a little bit later than we wanted to for our early date, but just given our conditions, that's when we did it. So then we had an early May long weekend this year. So we went just after our May long weekend for our normal seeding date, and that was May 19th. And then I think June the 3rd, I think, was our late date. So we always try and push it into June, which every time I hear the word seeding in June, I just kind of get a little icky feeling. So that's good. That's what we want for this study. And there's a couple really interesting things to look at. So I got some charts, and I've got a 2020 plant stand, and this is from these plots this year. And what you can see is when we're seeding our hemp, there's a line across the chart here. And what that is that's our optimum plant stand, and that's based on one of those response curves for yield. And so if we're in about 100 to 125 seeds per meter squared, that's kind of our optimum stand of hemp. So if we plant at a normal timing here, the only one that really drops below was when we really tried to cut rates. So we've got 3 seeding rates that we chose. We chose 100 seeds per meter squared, 250 seeds per meter squared, and 400 seeds per meter squared. With a kernel weight of about 13 for Finola, that makes this 250 seeds per meter squared, that's about the 28 pounds an acre that they're gonna suggest that you seed at. This 40, that's like 40 pounds an acre. That's like the high rates that a fiber producer might use. And this 100, this is like 10. This is like, you're really gotta be pretty bang on to get a good crop off there. So at our normal timing, we found that really even at the 100 seeds per meter squared, we kind of got away with it. We had 80% emergence essentially at that timing. And one of the interesting things is that the more you try and increase your seeding rate, the lower your percent emergence becomes. So at a low seeding rate, say a seeding rate of 100 seeds per meter squared, we got 80% emergence. If we bump that up to 250 seeds per meter squared, we're getting maybe 60% emergence. And we go up to 400 seeds per meter squared, we're not even 50% emergence. We're getting like 40% emergence. And you can see that's because, you know, look how thick and dense our crop is. There's so much intercrop competition. And hemp is a crop that is especially adept at self-thinning. And so we've got plot portions marked out that we did these counts on really earlier in the spring. We're going to count those same spots again later, and we're more than likely in a lot of these higher seeding rates just going to find that some of the hemp just couldn't keep up and just kind of withered away. So that's our normal seeding rate. So normal seeding rate, we really haven't seen an advantage to seeing dense. Now, if I was to show you the plots, I think maybe you'd disagree. But when we look at the yields from last year, we haven't seen that advantage really yet. The advantage may be logistical, it may be harvestability, it may be other field scale type things, but it doesn't translate into a direct grain yield in our small plots. So now if we jump down to the early, or let's going to jump to the late. Let's pretend we had a really bad year, gopher infestation, early storm, something took out our crop, and we're reseeding hemp. Because frankly, from what I've seen, is some crops, you get past that June 1st date, you're not going to get anything. Hemp, you may have a reduction in yield, but it's probably one of the smaller reductions compared to some of the other crops we grow here. So if we're going to seed a hemp crop later in the season, how high do we have to seed that to hit our optimum plant stand? Well, the 100, we had maybe 20% emergence. 250, I mean, we're up above 50% emergence, but, actually not 50%. We're close to about 25 there, I think. We really had to go 400 seeds per meter squared to hit that kind of threshold seeding rate. So I got some of those plots marked out. Maybe I'll just take you on a quick tour and show you where those are. So obviously, okay, the late ones are going to be the really small crops here. So I'm just going to start right on this end here. So this is our theoretical late seeded hemp crop, and we only put 100 seeds per meter squared down here. You can see we've got some pretty big patches that are missing crop. I mean, this is with our air drill, so it's a little bit exemplified, but I got almost a half a meter here and another half meter there where I don't have any crop coming up. Got some dense patches in the middle. I'm not worried about stage so much. This is going to fill in. It's just a poor competitor right now. One of the things you might notice, though, compared to a different seeding rate, is that we were able to get a good burn on this. So we don't have a lot for competition right now in this plot. So that's maybe like I said, the saving grace of later seeding. If we jump up to the 400 seeds per meter squared, we've got a full, complete, dense row across all of our rows. And I think if I was going to be late seeding, I think I'd much rather see that than the 100 seeds per meter squared. And this is our optimum, and this is our usual seeding rate, and I think it looks okay. So our usual seeding rate, 250 seeds per meter squared, it's seeded late. I mean, I think there's nothing wrong with this, but when you compare it to the higher rate, you know you've got that really thick, good stand. I mean, this could yield. We haven't seen in the past a big significant difference. So ironically, if I look at grain yields from what we saw last year, the early or the low, medium, and high rates, when we seeded late, there really wasn't a big difference. I think hemp is plastic enough; it'll compensate even with a normal seeding rate or a high seeding rate or a low seeding rate. A couple months from now, it's going to be compensated and filled in fully. At our normal seeding rate, what we saw was sometimes the low rate yielded really well. Most of the time, the normal typical rate did the best, and actually the higher rate didn't seem to do as well, and that could be for a number of factors. So let's talk early now. If we're going to go in and seed early, that's where we're going to see our biggest plots that we're going to see here. So I've got a Finola seeded early, May the 7th, at 250 seeds per meter squared. If I was going to go out, if I was a farmer and I was going to go out and seed hemp, that's probably what I would want to do. That just based off what I know, this is what I'm aiming for. And so that's what we have here. And interestingly enough, we can compare this to our low rate and our high rate, and I don't think this is the best looking of the bunch. If you walked out into a hemp field right now and you saw this, I think you'd walk away totally happy. But if you came over here and compared it to my high seeding rate, which is right here, I think it's pretty different. There's a lot more darker green here. It's a little bit taller. Like we said, like sometimes those high seeding rates just have that competitive boost between themselves. You know, they're really out competing any of the weeds. I mean, there's a pretty thick carpet of weeds down there, but they're never going to grow. They're not getting any sunlight at this point. So, you know, in terms of optimal stands, that one's perfectly fine. This one's perfectly fine. The 100 seeds per meter squared, where is that? That's here. This is our early seeding with 100 seeds per meter squared, and this is where we kind of see those dangers of cutting rates too much. I mean, this would be, you know, timing-wise, probably pretty optimal for grain yield. In fact, if you look at what we've seen in grain yield from our early timings, compared to normal and late, our early timings seem to yield better. We saw that last year. But our medium and high rates were about 60 bushels an acre on small plots. Our other timings, normal and late, were 50 to 60. But if you look at our early, we had a huge spread. We had a huge range depending on the rep and that sort of thing. But we had a spread from like 70 to 90 bushels an acre. So we really want to kind of get to the bottom of what's going on here. I think hemp is very able to compensate. It can branch out, which you kind of want to avoid for harvestability. But at the same time, just looking at these plants here, you can see, you know, we've taken measurements on how tall the plant is, on the length from the ground up to where the seed heads start, and you've got really big, thick, tall pollen here, and you're going to see the same thing when the females start to show. So this is a really interesting study, and I hope that we'll get some more site years here and have a little more confidence in what's going on with that data. So to summarize this rate by date study, I think, you know, hemp it's able to seed later, but it's really important to make sure you get a good stand if you're going to do that. And really in southern Alberta, what we've seen is that the earlier seeded hemp just seems to do better. And we'll see. We'll put this one on the back burner for now and see whether or not cutting rates is going to be beneficial or not. But I think definitely seeding earlier is a win for us here. So we're going to hop on down now to look at some of the planter stuff and kind of tie in what Ken had talked about with the strip till and the planter, and kind of tie that into what we're doing with the hemp and some of the seeding rates here. So that'll be a really kind of interesting jump. We just got to kind of hopscotch the cameras over. Those are now being funded through the Canadian Agricultural Partnership, and that's a joint funding through federal and provincial streams. This is also funded by Canadian Agricultural Partnership, but this is a different study. So this is looking at adapting those row crop planters to different crops throughout Western Canada. So we've actually aren't doing this in central or northern Alberta. This is just here, and this is also working with the pulses and some corn and things like that within this program. So the reason I wanted to show this though was because it ties in really nicely with what Ken talked about and with the seeding rates and seeding dates that I just showed you. So, you know, obviously the first thing that we need to do when we're changing row spacings and we're working with the planters, we wanted to look at seed safety. And so our delivery system for phosphorus is some sort of liquid 1034, something like that, placed directly in with the seed at the time of seeding. So we tried to recreate that bar chart in the field. We have a 0, 5, 10, 20, 40, and 60 kgs per hectare, straight P2O5 directly with the seed. So it's a really, really subtle bar chart, and it doesn't quite go the way we would expect it to. So we've actually seen that we have a nice starter pop-up type effect, and as we increase the phos rate, we seem to see a little bit taller, a little bit more vigorous, a little bit more robust looking plots, and we're expecting to see it look worse at a certain point, but we haven't really been able to make that happen. And so our drill, the most we can put down is about 60 kgs per hectare P2O5. And I think this year those plots actually look the best, or the greenest, or the darkest, maybe even the tallest. However, we did do stand counts, and we have found, oh, that's on this one. We have found that last year and this year, we saw a bit of a stand reduction. And so when we do our counts, we're pretty consistent because we're not changing all that much from treatment to treatment, but we do hit a point at about after 40 kgs per hectare where we are injuring the seed, we are seeing a reduction in stand. But because we're using a planter, and because we planted all this at 250 seeds per meter squared, that bar, that optimum plant stand, we never even really come close to falling below that. So if we look at our yield, we had a really, really flat yield across all of our fertility trial here. We never saw a response, and that's kind of a good thing. It's kind of a no result is a good result in this case. We wanted to make sure that higher rates of liquid phos aren't injuring the seed, and from what we've seen, they aren't until they get so extreme that your equipment probably can't do it, and you probably don't want to do it anyways. So that's kind of the phosphorus study in a nutshell. And then the fun part here is comparing the air drill and the planter. I always like comparing different setups, different systems, and then playing with the seeding rates and other variables to basically see, it's kind of like a competition. You know, my crew works on the air drill, and usually somebody else can, or somebody will be running the monosem in tandem, and you know, we're all tinkering, trying to create the same conditions. So we're trying to all seed at a half an inch. We're making sure we're using the same fertilizer blends. We're all using liquid kits. We're calibrating and trying to parallel each other as best we can, and then let the equipment kind of do the talking. Let the setup be the one that says, okay, you know what, it really is, in this case, the planter or the air drill that's doing a better job. It's not just the driver or the setup. So what we've got here is just a really simple study. We've only got 4 treatments. We've got our monosem, and we've got our air drill. And then we multiplied that. We did a normal seeding rate, that 250 seeds per meter squared. And then we did a cut seeding rate. And we said, okay, well, if we're using a planter, maybe we can cut back and we'll go half that. So a little bit more than we were doing in the other study, but 125 seeds per meter squared. That's still a pretty significant reduction. And you can see a couple pretty interesting things. So we'll just go on a little tour here. So this first plot, this is our air drill. This is 250 seeds per meter squared. We seeded this kind of in between our first and second date there just because of logistics. But you can see this is a really nice looking plot. I'd be totally happy to have a whole field of hemp looking like that right now. And then right beside me is our air drill at 125 seeds per meter squared. Now I think if you didn't have the comparison, I don't think a lot of guys would be too unhappy with that. But there's definitely a few obvious things going on. If we look at our plant stand, at our 250, we hit our optimum. This is an optimum stand. At our 125, we're just below that. We're about 75 seeds per meter squared. And so, you know, the plants themselves are a little maybe lighter. They're gonna have to branch a little bit more. The stalks may end up getting thicker. We may see big, thick heads. And it may not be ideal harvesting conditions. If we go and look and compare at the planter, you know, we do talk up our planter quite a bit here, and it's not as visual this year as it was last year. Last year, when our plot was maybe 4 or 6 leaf coming out of the ground, it was night and day, the planter versus the air drill. We've kind of filled in at this point in the season, and you lose the perspective, but this is a monosem on 12 inches at 250 seeds per meter squared, and that's a great looking crop. If you had a field full of that, I think you'd be really happy. And this is the one that's a little surprising this year. Last year our monosem at 125 seeds per meter squared, I think looked better than our air drill at 250. But this year we don't quite see it as much. But it's not insignificant. And excuse me, if we look at our 2020 plant stand, we see kind of a similar thing, but not as drastic as last year. So with our air drill, we've got our 250 seeds per meter squared. In either case, that hits our optimum rate. But neither one of our cut rates really made it up. And in this case, in 2020, our 125 wasn't quite as good as I suspected it to be. And I suspect that's like Ken said earlier, we had a little bit of seeding issues with one opener here, and you can see every once in a while it's really minor, but this one row doesn't look like it came up a little bit later, and it's not as robust. So we just haven't seen the effect here quite as much. But even in 2019, we almost hit our optimum at the lower rate. So, you know, when we look at, did I put yields here? I put the yield down along the bottom here. And so our planter, oh, sorry, I did them backwards. Our air drill is actually, it's painted red. So the air drill is supposed to be red, but in this case it's blue. And our 125 and 250 seeds per meter squared, there really wasn't a difference there at all. And in fact, what's really weird was that our 125 looked great, but it's about the same. It almost went down in yield last year, but it wasn't significant. It wasn't statistically significant. And we really didn't find a difference. And it's another one of those kind of no result is a good result, because it means a couple of things. It means that, you know, with our planter, we were able to cut rates a little bit and not see the effects. Whereas with the air drill as well, but slightly different spacing. I not sure I'd make 100% the same conclusion on the other plots, but it's really interesting to see what's going to happen here. And yeah, kind of looking forward to getting the yield from this year as well. Are there any questions yet? I feel like I've given this talk a couple of times, so maybe you've heard it. I hope you've learned something new and seen some new results. And every year we're just going to keep kind of building on this. I think in the future we may incorporate some strip till stuff into this. We may have to adjust and play with some row spacings and kind of work out some of that nuance. So thanks for tuning in. If you do have any questions, just give me a shout. Thank you.